Just in, PTFE, one heck of a material. Stay tuned for more.
Polytetrafluoroethylene, better known as its trademark name Teflon, was discovered by accident in 1938 by the chemist Dr. Roy J. Plunkett in New Jersey while he was working with refrigerant gases. After a sample of tetrafluoroethylene gas was compressed in a container, it was discovered that the sample had polymerized into a white solid. It is one of the most valuable technologies that was ever invented and is a vital resource to the aerospace, communications, electronics, and architectural industries. PTFE is most commonly known for the several consumer products that are made with Teflon fluoroplastic resins, which are known for their exceptional heat resistance, chemical resistance, and stress-bearing abilities.
Tetrafluoroethylene is synthesized from the reaction between hydrofluoric acid and chloroform, followed by the thermal decomposition of difluorochloromethane gas. PTFE is polymerized using a free radical polymerization under pressure to create a chain-like polymer. The fluorine groups on the chain take up a large amount of space around the molecule and cause an important steric property of PTFE. Instead of zigzagging on a single plane, the fluorine atoms create a tight spiral around the carbon chain, causing an interlocking force which contributes to the molecule's rigidity and high melting point. The structure of PTFE is the reason behind many of its unique properties.
PTFE is insoluble in almost every solvent. The lack of polarity in the polymer makes it insoluble in most polar solvents. Additionally, any dispersion forces of nonpolar substances, like grease, are not strong enough to stick to the PTFE. This is because of the fluorine's high electronegativity. PTFE has a very low tensile strength of only 3 to 4,000 psi. This is because there are only weak dispersion forces between the polymer chains, and it is quite easy for the chains to slip by one another as they are stressed. PTFE has a very high melting point of 327 degrees Celsius and is highly crystalline. These two properties are due to the bulky fluorine groups aligning and being attracted by van der Waals forces.
PTFE is very difficult to process when compared to other plastic materials. As a result, PTFE is typically processed by techniques used for metals and ceramics such as sinter molding, ram extrusion, or hydraulic pressing. After being processed, the material is cooled and then can be drilled or shaped.
PTFE is mostly known as the coating on nonstick pans, electrical insulation, and Gore-Tex clothing. While PTFE is used for many applications, there are a number of problems associated with it, such as its low tensile strength, which makes the material more prone to scratches. Because of PTFE's problems, alternatives such as ETFE, PFA, and PCTFE were made. These alternatives have a high tensile strength and a lower melting point of about 300 degrees, which allow for molding. However, these alternatives are more expensive to manufacture. In today's industry, PTFE will continue to be an important material for high-performance products.